Today we're going to start off with some more discussion of the .NET framework and how it executes your code and how it interacts with the code that you write. Now yesterday we said that the .NET framework runtime is a protective bubble that wraps around your application. It prevents you from worrying about things like allocating and deallocating memory for your variables, like we learned about yesterday. In some cases, it protects the end user's machine from unauthorized access to certain resources like hard drive. It's basically a protective layer that has some benefit to both the developer and the end user. And so I want to discuss a little bit more today about how that all works. Okay, so let's start at the beginning. When you write C# code, in order for that code to actually execute and do something, it has to be compiled. There's a process called compilation that converts your human-readable C# code into machine-readable code, I guess you could say. The end result of compilation is a file that's called an assembly. And there's two flavors of an assembly. There are exe files and DLL files. And just so you know, for the next week or so, we're only going to be building exe files. The exe file extension means that it's executable, which means that you can find it in the Windows Explorer, you can double click it, and something will begin to happen. It'll begin to execute. The DLL file, it stands for Dynamic Link Library, and it's lost a little bit of its original connotation from 20 years ago. But basically now, it usually means that it's a supporting library of code to be used by other executing code. We'll talk about DLLs later when we talk about architecting your applications for reuse. So the entire compilation process happens in two phases. The first phase happens whenever you either begin debugging or you explicitly compile your application. Up to this point, we've only been debugging our applications. We'll talk about the difference in just a second. When you begin debugging, a debug version of the assembly is added to the debug folder in your project. And if you recall, we saw that yesterday at the beginning of the day when we built our first application. Then we went through the Windows Explorer and found that debug version of our application. A release version of the assembly is created in the release folder. So what's the difference between the two? Well, the debug version of the assembly has some additional information added to the assembly to enable the Visual Studio IDE, in this case Visual C# 2010 Express Edition's IDE, to participate in the execution of the application in debug mode. So you will see this a little bit later today. You can set a breakpoint in your code and step through each line of code, and what it's really doing behind the scenes is stepping through the equivalent line of code in the compiled version of the assembly. We'll talk about debug mode, debug time in just a minute. But the debug version of the assembly requires some bookmarks so that the IDE can keep in sync with the code that's in the assembly. And this will make a little bit more sense when we start debugging our applications, again, later today. If you want to give your application to somebody else, however, at a minimum, you're going to need to give them the release version of the assembly, and they're also going to have the .NET Framework runtime. Since you're using 2010, they're going to need to have the .NET Runtime 4.0 or 3.5 installed on their computer. Ideally, what you wind up doing is creating a separate application called an installation application. And this installation application takes care of all of the details of installing your app to the right folder, installing the .NET Framework runtime if it doesn't already exist on the end user's computer, and so on. And later on, we'll talk about that. Let's hold off on that. Again, table another topic. Sorry, a lot of tabling going on here. Let's get back to the idea of compilation. Compilation, during the compilation process, the compiler is an application that takes your C# code and turns it into this file, and it does a few things during this process. First of all, it goes through all your code, and it makes sure that you didn't make any obvious mistakes. Now, there are certain errors that you're prevented from making, otherwise the compilation process would end and force you to fix the problems before trying again. That's the kind of error that we're talking about, just some initial checks to make sure that everything looks on the up and up. And then once it passed that check, it converts your C# into a different language called the Common Intermediate Language, or the CIL. You'll also see it referred to in books and articles as just the Intermediate Language, or IL. This allows you to write an application in Visual Basic or C# or J++ or any other .NET programming language. They all get compiled down to CIL, Common Intermediate Language, or IL, Intermediate Language. The third step is that the compiler adds some bootstrap code that whenever you double click that exe, it will then bootstrap and say, I need to refer you to my friend the .NET Framework runtime. So it pulls up the runtime, and then the runtime loads your exe into it, your assembly into it. Basically, the exe will say, wait, I need to make sure that I'm running inside of the .NET runtime before we get any further. If it isn't installed on the computer, then the program will just die. Okay, so all of that is really the first step of the compilation process. The second step of the compilation process is called just-in-time compilation, or JIT. People can run your application on a variety of versions of Windows, and each of those computers that run Windows have, an infinite number of hardware configurations. But here again, the .NET Framework saves you from having to worry about all that low-level stuff about this version of a video card versus that version of a video card, and this hard drive configuration versus that hard drive configuration, and motherboard, and all that stuff. So this is really a big win. You don't have to worry about any of those low-level details. The JIT, or the jitter, the application that takes that common intermediate language version of your assembly, it will then look at it and then compile the best version based on your version of Windows, your hardware, and so on. So again, the very first time your application is run on a new computer, the .NET runtime evaluates the computer's operating system and its hardware, and it creates an optimized version of the assembly that's specific to that configuration, and it saves the application in a cache, in a special area on your end user's hard drive. So from that point on, the .NET runtime will use that special optimized version that's in cache. Now the important point is that you see absolutely none of this. If I didn't even tell you about this, you might really never even know that what was going on behind the scenes, and that's perfect. But I do think that having a little bit of this knowledge can help you understand why you need to compile, and why there's a debug version versus a release version, and so on. There's a reason for all those steps that you have to take, even if it's not readily apparent at first. Okay, so that's the first part of our discussion this morning. The second part of the discussion will be about the various states of the IDE. So they have a name that you'll see in books and articles and even in our videos, and that is design time. It's a state of our IDE, which refers to those activities that take place while you're writing code. As you'll see when we're working on the canvas to build forms for WPF applications, Windows applications, that whole process of writing code and working with the designer inside of Visual Studio's IDE is called design time. You're working on your application. You're the main actor during design time, the developer is. When you decide to debug or compile your application, that process of creating the debug or the release version of the assembly is called compile time. Now, admittedly, when there's not a lot of code, that happens so fast that you barely even realize that anything's happening. It's a very short period of time relative to the amount of time it took to write the code, but it's still considered a time, a state of the application, or of the process of building an application. There's certain activities that happen during this state. So during compile time, the C# compiler is the main actor. It's the one that's hard at work, as we noted earlier. It stops and forces you to fix bugs, or it outputs an assembly, the output being an exe or a .dll file. So then the next state is runtime, and that's when your application is actually executing. And during this time, the .NET Framework is working with the compiled version of your code to perform the instructions that you programmed. Also during this time, unexpected problems or bugs can pop up. They're called exceptions. And exceptions happen because something outside of your control or perhaps something you did caused the application to be in a illogical or problematic state. So there's two types of bugs, really, when you think about it. There's the type that your boss has, the problem that your boss has with the application. Your code instructions aren't performing the way that he wanted, or the requirements that he gave you, you didn't follow them, and so that is considered a bug. That's not the kind of bug that we're talking about, not the kind of exception that we're referring to here. What I want to focus on right now are the problems that the .NET Runtime has with your application, which cause the application to stop executing, to stop performing. Later this week, we're going to learn how to write code that can safeguard against your application running into something unexpected. All right, and finally there's debug time. This is kind of a mix between design time and runtime. In this state, it's sometimes just referred to as debugging. And while you're debugging, you're running your application in such a way that the C#, Visual C# 2010 Express Edition IDE can allow you to step through each line of code and inspect the values that are currently stored in your variables, to change the values of the variables outside of the application, and see what's going on generally behind the scenes. And this is a very, very important feature of the IDE, and we'll commit a few videos to learning how to master this skill because it is extremely valuable. Entire careers are made at learning how to debug code and how to fix problems with other people's code. Okay, so to recap, 3 things in this video. First of all, your code gets compiled into an assembly which contains an intermediate language known as the intermediate language or the common intermediate language. 2, your code then is compiled just in time the very first time that it's run on each new computer so that an optimized version can be built, and from that point on the .NET Runtime looks for that cached version that it built and it uses that from that point on. And then third, in this video, you need to understand the different states of building and working on applications. There's the design time, where the developer is the main actor, the developer is doing all the work. Compile time, where the compiler is doing all the work. There's runtime, where the .NET Runtime is doing all the work, and then there's debug time, where the runtime works together with the IDE, the Visual Studio IDE, to help the developer watch the code execute line by line. Okay, now that you have that background, hopefully some things will start to make a little bit more sense. And fortunately for you, that's about the most complicated part that you're going to have to review for today. So the rest of today is a total cinch, and you get to expand your C# vocabulary dramatically. And tell you what, we'll see you in the next video and pick up from here. Thank you.